This is a very interesting question. The question reads as follows. Two customers, Sham and Ekta, are visiting a particular shop in the same week from Tuesday to Saturday. So there are totally 5 days. Each is equally likely has to be highlighted here, to visit the shop on any day as on another day. What is the probability that both will visit the shop on the same day, on consecutive days, and on different days? So let us just collect what is given in the question, right? You have 5 days, and 5 days from Tuesday to Saturday. So let's say day 1 is Tuesday, day 2 is Wednesday, it goes on till day 5, that is Saturday. Okay. Now they also mention that each day is equally likely. That means probability of anybody visiting a shop on a Wednesday is same as the probability of anybody visiting a shop on a Friday. It makes no difference. Okay. Now this question is actually very similar to a dice question, but since it is worded in a different way, it appears to be tricky. Let's see how it is similar to a dice question. Okay. Now let's tabulate all the possibilities. Okay. This side of the table is the days on which Sham is visiting. This side of the table is the days on which Ekta is visiting. Right. Now 1,1 here refers that Sham is visiting on a Tuesday and Ekta is also visiting on a Tuesday. Right. 1,2 means Sham is visiting on a Tuesday while Ekta is visiting on a Wednesday. Same way, 2,1 means Sham is visiting on a Wednesday but Ekta is visiting on a Tuesday. Like this, you can fill out all the possibilities, right? So that means, what is n, the sample size? The total number of possibilities is nothing but this square of 5 into 5. So totally if you count, you will get totally 25 possibilities. Okay. So this will be the denominator in our calculation, right? Now they want us to find probability on the same day. That is, both Sham and Ekta going to the shop on the same day, right? So we know that probability is nothing but total outcomes, the denominator, and favorable outcomes in the numerator. Okay. So let us just count. We know that the total outcomes is 25. So for them to go to the shop on the same day, how many favorable outcomes do we have? 1,1, 2,2, 3,3, 4,4, 5,5. We have totally 5 favorable outcomes. So the probability of them going to the shop on the same day is nothing but 5 by 25, which is also 1 by 5. Now you notice this problem is very similar to a dice problem, where you roll 2 dice where the numbers on the dice are from 1 to 5. It is just worded in a different manner. Here the shop is nothing but the dice. Okay. Once you understand that, this is quite simple. Okay. The next we have to calculate the probability of Shyam and Ekta going to the shop on consecutive days. Okay. Again here the total possibilities are 25. So where are the consecutive days? So that means if Shyam goes to the shop on the first day, Ekta has to go to the shop on the next day, that is 1,2. So if Shyam goes to the shop on the first day, Ekta has to go to the shop on the second day, like this possibility over here. Okay. Also, if Shyam goes to the shop on the second day, Ekta can go to the shop on the third day. If Shyam goes to the shop on the third day, Ekta can go to the shop on the fourth day. If Shyam goes to the shop on the fourth day, Ekta will go to the shop on the fifth day. So you have 4 such possibilities. Now that means in the numerator you have 4. Now you have to be very careful here. They are not mentioning that Sham has to go first and Ekta has to go second. That means Ekta can also go first and Sham can go second. That means here if Ekta goes on the first day, Sham can go to the shop on the second day. So you will have 4 more such possibilities: 2, 1, 3, 2, 4, 3, 5, 4. So these here are the cases of Ekta going first and Sham following on the next day, and these 4 here, the ones that we marked first, are the cases where Sham goes to the shop first and Ekta goes to the shop on the next day. So totally 4 possibilities where Sham goes first and another 4 possibilities where Ekta goes first. So totally you have 8 favorable outcomes, and total outcomes is 25. So the probability of Sham and Ekta visiting the shop on consecutive days is nothing but 8 by 25. The third part of the question is probability on different days. That means Sham and Ekta going to the shop on different days. This is nothing but 1 minus probability of them going to the shop on the same day, because either they go on the same day or they go on the different day. So it's quite straightforward. It's nothing but 1 minus, we have already found the probability of Sham and Ekta going on the same day, that is 1 by 5, which is equal to 4 by 5. In case if you want to count like we counted for the other 2 possibilities, you can do it also. Total number of outcomes on the denominator is 25. Let's count the favorable outcomes. That is Sham and Ekta going to the shop on different days. Okay, so we have 4 different cases here on the first row: 1, 2, 1, 3, 1, 4, 1, 5. This gives you 4 in total. Same way, if Sham goes on a Wednesday, Ekta can go on Tuesday, Thursday, Friday and Saturday. 4. Then again, if Sham goes on a Thursday, Ekta must not go on a Thursday. She has to go on a Tuesday, Wednesday, Friday and Saturday. Again 4. Similarly, you will have 4 for all cases. The total will be 20. Same way, put here on the numerator 20 and denominator we have 25. Favorable outcomes is 20. Non-total outcomes is 25. So totally again this will come out to be 4 by 5, which is same as what we calculated before. That is, probability of Sham and Ekta going to the shop on different days is nothing but 1 minus probability of Sham and Ekta going to the shop on the same days, which is 1 minus 1 by 5 equal to 4 by 5.